Tesla has always had a record of creating incredible products, and it's clear they plan to keep producing even more groundbreaking ones in the future. The company continues to scale up production and has shown a level of creativity that's extremely rare in the automotive world. Without question, Tesla stands as the most innovative car company in the industry today. From the earliest days of leading Tesla, Elon Musk made it clear that Tesla would never be just another electric car company. What many in the industry thought was impossible or even ridiculous, Elon Musk decided to make real. That's why Tesla has released a series of bold and unconventional products like the Cybertruck, Optimus robot, Cybercab Robotaxi, Cybervan, and now the Tesla flying car. The next project meant to prove Musk's daring vision. This new project has already been leaked as part of Tesla's future product lineup and production roadmap at Giga Texas. Of course, Tesla isn't the first to explore the concept of a flying car. Companies like Klein Vision have already showcased their own versions, though at very high prices. Tesla, on the other hand, claims it can manufacture a flying car for just $6,189 by using parts already developed for its EVs, dramatically reducing R&D costs. That means it would cost about 1/16 the price of a Model 3. Sounds unbelievable, right? So how could Elon Musk possibly pull this off at such a low price? Let's take a closer look at how this could be made possible. When most people first hear the term flying car, it sounds like a joke, something straight out of a sci-fi movie. If you weren't watching this video, you'd probably think it's just another clickbait headline. Yet this is a real type of vehicle that's been gaining a lot of attention recently, aiming to completely change how we travel. Faster than driving a car, but far simpler than piloting a plane. Before taking this project to Tesla, Elon Musk likely studied the potential shown by early innovators. According to our research, Klein Vision was one of the first to successfully bring this concept to life. To understand the Tesla flying car better, let's quickly look at Klein Vision's flying car as an example of how such vehicles actually work. Klein Vision's model runs on a gasoline engine and is offered in 3 versions, 280, 320, and 340 horsepower, levels you'd normally find in high-end sports cars or performance SUVs. Even though it can fly, it still has standard car pedals and controls. The wings are folded into a special compartment, and the tail folds neatly for driving on roads. The company says it can safely reach speeds up to 124 mph on the ground. With 3 fuel tanks holding 42 gallons, it can travel around 497 miles on a full tank. When in car mode, the air car measures about 6.6 feet wide, 19 feet long, and 5.9 feet tall, roughly the same as a Rolls-Royce Phantom, though slightly taller. Its aerodynamic design and composite structure make it look sleek and futuristic. What's truly impressive is the weight, just about 1,764 pounds, which is extremely light compared to a Phantom's 7,500 pounds, despite similar size. This lightness is likely due to specialized lightweight materials and a monocoque chassis instead of a traditional steel frame. The body's smooth curves help reduce air resistance at high speeds, and the large windshield gives the driver a panoramic view, especially useful in crowded urban areas. However, this vehicle seems best suited for paved roads, not rough terrain. Its large size also makes it harder to park or turn in tight spaces. Interestingly, Klein Vision's design uses 4 wheels instead of the more common 3-wheel layout seen in other flying cars. This decision raises manufacturing costs and regulatory requirements, but shows their confidence in building something closer to a real car than a lightweight air bike. Every line on the vehicle's surface appears carefully refined for better airflow, improving performance both on the ground and in the air. Switching to flight mode takes less than 2 minutes. You drive it to a runway, press a button, and it transforms. The wings unfold to a span of 26.9 feet, and the tail extends backward into flight position in about 80 seconds. The engine then disconnects from the wheels and powers a rear propeller. After a quick safety check, you're ready to take off. According to Klein Vision's co-founder Anton Zajac, the vehicle can cruise at 155 mph, fly up to 621 miles per trip, and reach altitudes around 10,000 feet. It's already received airworthiness certification, logging over 170 flight hours and 500 takeoffs and landings. That's how a working flying car from an experienced company operates. But Tesla's flying car will differ in several major ways. The biggest difference is that it's expected to be fully electric, not powered by gasoline. Using Tesla's advanced battery systems, it can offer quiet, emission-free travel with far lower operating costs. Since batteries are one of Tesla's greatest strengths, this gives them an edge. However, the main challenge will be balancing weight and power. Too large a battery makes the car too heavy, too small, and it won't generate enough lift or energy for flight. The solution is likely Tesla's 4680 battery cells, known for their high energy density, up to 300 watt-hours per kilogram. These cells allow the car to store more energy without adding much weight or size. This could provide enough power for flight while keeping the car light and compact. Still, designing a flying car isn't just about attaching wings to a Tesla. It requires cutting-edge aerodynamics, stability systems, and meeting strict aviation standards far beyond those for normal vehicles. While Tesla hasn't officially shown the final design, it's rumored to resemble a smaller, sleeker version of the Roadster, built for maximum aerodynamic performance. Elon Musk has said the Roadster can accelerate so fast it feels like it's flying, going from 0 to 60 miles in less than a second. For the flying car, Tesla may borrow some ideas from SpaceX, Musk's aerospace company. Instead of using traditional propellers, Tesla might use compact electric jet engines based on SpaceX propulsion tech, but optimized for electric flight. This would make flying cleaner, quieter, and more efficient. Tesla could also include Falcon-style vertical landing technology, allowing smooth takeoff and landing without long runways. The lightweight frame will probably be made from advanced aluminum alloys and carbon fiber, with gull-wing doors and a retractable wheel system that folds away during flight. With one button, the vehicle switches from car to flight mode in about 90 seconds. Two multi-joint wings unfold, and the rear extends for balance. The wheels tuck into the body to reduce drag. On the ground, the car runs on dual electric motors, one front, one rear, giving it a 0 to 60 mph time of around 3.9 seconds, along with Tesla's autopilot and supercharger access. Safety, as always, will be Tesla's top priority. The car will include a full-body parachute system for emergencies, and landing pads that deploy to absorb shocks when landing on uneven surfaces, a new safety feature unseen in other flying vehicles. Tesla's use of multiple small electric motors also provides redundancy and better stability. Each motor is easy to replace, uses thinner wiring, and needs smaller speed controllers, improving reliability and reducing heat buildup. Even if one motor fails, the even thrust distribution helps maintain balance in the air. Each motor uses only about 1.7 kWh, yet the car can reach speeds up to 248 mph, faster than most other eVTOLs. Its range could reach around 300 miles per charge, far exceeding most current electric aircraft, thanks to its efficient design and powerful 4680 cells. Unlike other air vehicles with large spinning blades, Tesla's design hides ducted fans within the body, reducing both noise and danger in cities. Production will take place at Giga Texas, Tesla's most advanced facility. It includes a virtual flight testing lab that can simulate real-world aerodynamic and AI performance conditions, helping cut testing time and cost. There's no official release date yet, but experts think prototype versions might appear as early as next year, with full production soon after. As usual, delays are possible, as seen with the Cybertruck, and regulatory approval will take time. But Tesla's experience in EVs, AI, and aerospace makes flying cars seem inevitable. It's not a question of if, but when. Some analysts expect Tesla's flying car to appear in select cities by 2026, with wider use by 2030. If Tesla manages to mass-produce it affordably, it won't just be another product, it'll spark a full transportation revolution. A target price of $6,780 would make it possible for millions to own one. Even if that price isn't achieved right away, it remains the long-term goal. Imagine waking up, walking to your driveway, pressing a button, and flying straight to work, skipping traffic completely. Or imagine cities built without huge highways, replaced by rooftop flight ports. Just like Tesla's EVs reshaped the car industry, the Tesla flying car could push the world into a new era of personal air travel. The key challenges ahead will be keeping costs low, meeting safety standards, and earning certification from aviation authorities. Tesla may switch to aluminum-ion batteries for further cost savings, but must also reduce expenses on ultralight materials and lift engines without cutting quality. Ensuring safety will require extensive testing, both for car crashes and for stable flight in poor weather. Tesla will also have to work closely with regulators since laws for flying cars barely exist yet. Once those hurdles are crossed, mass production can begin. And when that happens, Tesla's $6,989 flying car could change the world forever.